22. So we're going to go to 22. Then we're going to go to, I'm just going to do it quickly because I want to, I'm not happy with the white. So I just want to show you because at the end of this, I'm going to blow it up. So I'm going to go like this. I'm going to go maybe 32 point there. That's too much. Let's go with black. That's better. Okay. So you can see we started at 28, Sue. Every point along the path, I ask, where do you want to go? We want to go to the smallest place that we haven't yet visited with our spaghetti. Okay, so 28 goes to 22, 16, 10, 4, 3, 2, 1, 0, 6, 7, 8, and we wind all the way around. And hooray, we got to get our whole spaghetti down on our plate. It's nothing to do with where you start. It's all to do with the smallest number of the maximum four around your current position. Okay, so for example, if you are at 29 here, you've got the choice between going to 28 and 23. No, you don't. You've already been to 28, so your only choice is to go to 23. Okay, so that's it. Everything clear? Can I have thumbs up, or from everybody out there, just give me a yay or no. This is okay. Sloan, Donna, Daniela, good. So you guys are off by yourselves now. Try to join one of the lower numbered tables. I would like you in larger groups to just talk about this. You've got. How do you give a thumbs up? That's a good question because I don't see any thumbs. So you can just, how do you go to a table? You double click on one of those tables. So just double click and that should get you there. Good? Okay. So take 5 minutes. I want you to tell me about patterns whenever we come back. I want you to tell me the patterns of those ones that work, those ones that don't work. The beautiful thing about this puzzle, I'm just going to leave it for you to find out. Just enjoy. So 5 minutes, and we'll come back. Then I'll ask you to come back. Oh, okay. So you want to? We want to wait just a moment for tech support. We're getting all of the tables populated with these images and some more images. So I'm going to actually get you guys, whenever I am here, I'm going to get you guys to try to predict a number that does not work. Oh, your tech support is ready. So you believe one will not work. So I'm going to just see if that's true. And you guys can take off. So 0 goes to 6, 7, 8, 2, 3, 4, 5, 11, 10, 9, 15, 14, 13, 12, 18, 19, 20, 21, 22, 16, 17, 23, 29, 20. And this is the result. And I'm going to just go like this, go like this, go like this, and there we go. This actually worked. One worked. Darn. So really important to tell your kids, what kids are too often in grade 2, they're too often cautious about failing, about being successful. You mess them up and you stop that bad way of thinking by telling them, I want you to fail. I want you to give me a number that fails. So you play around with this idea of failure and success. Okay, go to your rooms and figure out what's going on. Take care, everyone.
I'm going to guess the ones that don't work are like 11, 23, 18, and 6. Oops, I'm drawing. Oops, I didn't mean to do that. How did I do that?
Did anybody see what? I'm trying to see. I never did get a chance to really see the image that he did.
I'm guessing.
So he went to 1,
I'm guessing
0.
this one. Oops. I'm guessing
Let's see.
6, 11, 23, and 18. I'm guessing those ones don't work. But I don't know. Wait, that might not be right. I might have got the wrong one. So. Oh, I gotta look at that again. Hard with this baby.
This is 1 to 0.
Oh, wait, that's right. That's what I'm thinking. Right. Those 4. Oh. Oh.
How are you guys doing? Yeah, that's for much later in the presentation. So, Angela, you think I should just start up again? You guys look like you're just playing around.
Well, I'm doing it on my paper, so that's why I'm not even messing with it.
Let me start up again. This just looks like fun, but it doesn't look like it's. So let me, if I click present here. Okay, everybody. So that looked like a little bit chaotic in those rooms. I've got a lot of slides, but those slides are for upcoming puzzles that I'm going to be talking about. Can you all give me a thumbs up or a yes? You can. Everything looks good. So any results that you guys found that you would like to share? Difficult to share, but go ahead. Sloan and Lori and Angela, what results would you like to share? Yeah, this is difficult. Let me share some. Let me share my screen, and then you guys can talk about it. So these are the results that I found. Is any number bad? Yeah. These are the numbers that I find that were bad. Do you guys agree? They're bad because they very quickly split the plate in two. Like if I take 31 here, okay, let's see what would happen if I started at 31. So I start at 31. Then what's the smallest number? 25, 30, or 32? Of course, it's 25. So I end up going all the way like this, and this is what I end up with. And let me just go to 32 and that. Okay, and I want this dark. And I actually want that the default. There. Okay, so if I start it with 31, I don't get all the way around my plate. I only get to 30. Right? Okay, so 1, we saw that 1 wasn't as bad. So let me just, I just want this to be the default. Come on. Good. I think this is now going to be the default line style. So let's check. So your suggestion is you tried 15. So the 15 goes to 9, goes to 3. This is much better now. Now you've got the choice of 2 and 4. Of course, you go to 2. It's smaller. Okay, and we're wandering around here. And you can see we're pretty happy because we're going to sink down into this hole, but then we're going to come out again. So 15 is colored correctly. Okay, you tried 11 and 27, and what did you think? 11 and 27, yes or no, Angela? $25 doesn't work, let's see. So 25 goes to 19, goes to 13, 7, 1, 0, 6, 12, 18, 24, 30, 31, 32, drops back down again, then goes over here. Each time choosing the smallest number that you have not visited yet. And I think the 25 actually does work. Okay. Okay, so 25 should be green, and it is green. So we've made the right color choice for that. Let's see. From 0, I can't go to the smallest one, but I can go to 6, question mark. From 0, of course, which is smaller, 1 or 6? Of course, 1. So you go to 1. Which is smaller, 7 or 2? 2. So that goes to 3, to 4. So starting with 0, yeah, this is pretty obvious. This is just going to snake all the way down the plate. And again, we want 0 to be colored green. And it is. Yay. Okay, there is suspicion that 6 and 11 will not work. Is that right? So I want to find ones that don't work. Okay, ones that are failures. Those are the ones that I'm interested in right now. So just text me some failures. 23 and 18 are failures. So let's look at 23. So 22, 29, or 17, which is smaller? Of course, 17 is smaller than 11, 5. So we go like this, we go back this way, winding this way. Each moment, we are choosing the smallest number. And again, 23 should be colored green. Have I just got all of the correct ones? 31, 32, 33, and 34. It looks like those are the only ones that fail. 18. So let's just look at 18. So which is smaller, 12, 19, or 24? 12. Which is smaller, 6 or 13? 6. Which is smaller, 0 or 7? 0. Which is smaller, 1? Oh, I have to go to 1. Then I have to go to 2 or 7. 2 is smaller. I'll go to 2. 3 or 8. I'll go to 3. 4, 5. Okay. Oh, this looks... Oh, again. 18 needs to be colored green because it is a success. Okay. So are people confused or are people getting this? because we're online, you just have to be honest because it's so hard to communicate online. Teaching online, I've been doing this for 4 months now. It is like a veil is over my face and I can't feel my students correctly. I think that they're with me, but I'm never sure. It's not the same as teaching in real life. Okay, everyone's good? So you like the, you think that this is, that we've got all of them. Those red ones are the ones that are failures. Okay. You guys, you're too sheepish because you try 11. Aha, Sue, I like that because exactly right. If we try 11, here we go to 4, to 3, to 2, to 1, to 0. 6, 7. It looks like this is going to be good, right? But sure enough, something goes awry. We end up at 23, and now we have the choice of 17 and 29. Okay, of course we go to 17. Okay. So all of this is on Math Pickle. This is called Uncut Spaghetti. So here we've made a mistake. This actually should be colored red. So I'm going to color it darker red here. There. So this is called Uncut Spaghetti on Math Pickle. But of course, you can just use a normal numbers chart. One of the mistakes that is used again and again in elementary school is that the number chart used is 1 to 99, 1 to 100, 1 to 100. The correct number chart obviously is 0 to 99, because then you're dealing with tens nicely organized. The second row has got tens plus the units, 0 units, 1 unit, 2 units, 3 units. The third row has got 30. So anyway, you get the idea. It should be 0 to 99, not 1 to 100. The flip chart, whenever you turn it over, that should be 100 to 199. Flip it over again, 200 to 299. So that's just a plug for 0. Okay. Okay. Let's, so are you guys confident now? Pretty confident that you've found all of the reds? Silence is a really a thing that is underused in the classroom. And often eye contact is intimidating. So whenever I ask a student randomly to contribute, and all students have to contribute in my class, I don't want to know what the top students think whenever I have the whole class together. I want to know what the average student thinks. I want to know what they all think. But that can be intimidating to look at a student and say, it's your turn, do it, do something, say something. Okay, that can be intimidating. Instead, I pretend to be working on this myself. So I'm going to pretend like you're the camera right there. I'm going to communicate right to you. And I'm going to say, it's your turn. Can you find another failure? Okay. I'm going to think of this myself. Where is this? So I look at the board. I'm not looking at you. I'm looking at the board. I'm trying to figure it out myself. Even if I know the answer, I look like I'm trying to figure it out myself. Or I often shut my eyes. I say, everybody, 10 seconds silence. Let's work on this together. What is another red number? Another number that I've falsely colored green that should actually be red. So you slow things down. You're trying to make methodical problem-solving space for all of the kids. If you are someone who encourages hands to go shooting up in the air to answer your questions, you are robbing those methodical problem solvers of the chance to succeed. Because if they find the answer, but they find the answer 10 seconds later than all those kids that have their arms shooting up, that's already a failure for them. A little failure. Kids are very sensitive to that. So you don't allow hands going up in most situations. To ask honest questions, yeah, but to say, oh, I know the answer. 4 is 4 should be red or 5 should be red. No, we slow things down. We make it methodical. We are the ones in control of the class. We choose which students are going to answer, and then we empower them. We slow it down. We think ourselves, and that's going to drive the top students in your class nuts. So how do you address those top students? Well, for 15, 20 minutes in the class, they need to learn to just sit, and they have to just keep it to themselves. Then you break them out into pairs, and then they can go nuts and express all of their genius. But for that first part where you're explaining the problem, you're slowing things down, you're making sure that you understand where everyone in your class is. Okay, 16, 17, I'm going to shut up. Absolutely, 16 is a problem. Now, normally I wouldn't say that in advance, so I'm not even following my own rules there. I would say, no, 16 can't be. Can it? So I'm skeptical. I go against students that are correct. Okay, can't be right. Oh, it is. Okay, so yeah, you're correct. So 16 should be colored red. Okay. So telling students that they are wrong whenever they're right is great. Mentoring what it is to fail yourself, being in that flexible position that you feel, okay, to go into a classroom not exactly knowing the answer. So for you to go into the class teaching Uncut Spaghetti without knowing the answer, what is the worst that can happen? The worst that can happen is that a child figures out something that you didn't figure out, and that you painted something green that should have been red or red. And you know what? That just makes for an exciting math class for those kids. You're on the verge. It's exciting for you. And you don't have to put in the prep time the day before to memorize the answer. If you memorize the answer to these types of problems, it's as if you are a bird teaching a bat how to fly. And that's just not the right direction. Okay, I'm going to shut up again. I could get onto a real diatribe here. Okay, 10. Okay, let's see if 10 is going to work. So 10 goes to 4. And yep. Go like this. And absolutely correct. We have a problem with 10. Yep. Okay. So at this point, I'm going to leave it. 22 is correct too. So now I'm talking to you as teachers, not as kids. So 22 is correct. There is another one for you to find. 4 is another one that doesn't work. And then there's one other one that doesn't work. And I might as well. So this here is, of course, not all of them because we're missing the 11. And this is the full solution. So the 2 is in there as well. What is beautiful about this puzzle and why I'm so proud of it is because you've got patterns here. And these patterns, you've got the 4, 10, 16, 22 pattern. You've got the 11 that looks like it's out by itself. You've got the 2 that looks like it's out by itself. And then you've got the 31, 32, 33, 34 pattern. And if we go to a larger grid now, and you can imagine that you might choose not to do this quickly in a classroom, but you might choose to go slower on it. But if you go to a larger grid, like 0 to 63, which of these patterns sticks? And how do those patterns look on a larger grid? So for you guys, I just want you to now sit back and enjoy. You don't have to work for the next few minutes. I just want you to think, how might that pattern look? And now I'm just going to tell you what the pattern looks like. So yes, you might choose to go and work on this, but I think sometimes it's just nice to relax. And here is the pattern for a 0 to 63. There it is there. So we have 15 and 31. So remember the 11 in the previous one? 15 and 31 looks like that. It's the same type of pattern. And then this 2 pattern, these ones all kind of belong to the 2 pattern. Okay, let's keep on going. This is 0 to 99. Again, this 11 pattern now is turned into an 19, 39, 59 pattern. I mean, this puzzle is just rich with beautiful patterns, and mathematics is so much about patterns. So one of my favorite puzzles. Okay, next. Many of you think about Venn diagrams, and you think about this being the end point of your discussion of Venn diagrams. So you ask all of your children to go up and to choose, where do you put your name? Do you own a cat? Do you own a sister? Do you own a brother? Okay, well, depending on your answers to those 3 questions, you get to write your name somewhere in this Venn diagram. So all of you take 10 seconds, figure out where you would write your name in this Venn diagram. Okay. So, Karen asked the question, do you allow students to draw on the paper? So what I do with my puzzle sheets is I hand out my puzzle sheets, 1 puzzle sheet to 2 children. I have many reasons for that, and I'll show you a failure that I had in my life. I always find failures are fascinating. So one time I went into a class and I had a beautiful puzzle sheet. And sure enough, one child wanted their own puzzle sheet. So I gave it to them. And I always come prepared. So another child asked me, and soon the whole class had their own puzzle sheets. I never do this. I always have 1 puzzle sheet for every pair. But this class, every child had their own puzzle sheet. And the children were super engaged. They were coming up to me. I had so many kids lined up to wait to talk to me that I told another student, you take over for this line and assess some of these answers coming up and tell me and tell the kids good or bad. So everything looked really good engagement. So everything looked really positive in the class. I went through 75% of the class and I walked around and I found one child, and she was sitting by herself and she had not got anywhere with the puzzle sheet. I failed her that day, and I realized that whenever you have a pair of children working on a puzzle sheet together, if they fail, they tend to fail in an extroverted fashion. If you have a single child failing at a puzzle sheet, they either fail in an introverted or an extroverted fashion, and it's very hard to tell. And as a teacher looking across the classroom, very difficult to tell a single child failing. But a duo failing, much easier. So that's the answer why I have one puzzle sheet for every 2 kids. Getting back to this. What is a natural question whenever you arrive at this 3 Venn diagram? Oh my gosh, of course, every person has to ask, is it possible to have a 4-person Venn diagram? Okay, you've got to be thinking like this. Okay, it is totally unacceptable to end any discussion on one of the most beautiful areas of mathematics and an active area of mathematics to be ending that with the 3-person Venn diagram without even if you just ask the question, I wonder if this is possible with 4 circles. Even if you just add that single sentence to the end of your Venn diagram, you are upping the quality of your lecture by double. For those top kids, you send them home wondering, I wonder if this is possible for 4 circles. 10 seconds, I want you to place your name into this Venn diagram. Okay. Yeah. So Donna just suggests I put a sheet of plastic. So absolutely, you can play with all of those. The important thing for me is that I have two children working on one sheet. I have had instances where sheets are pulled back and forth between two kids, and they've got like one pencil between them, and they're just going. For me, my classes aren't always quiet. I'll give you that. But that's a bit of joy to see kids fighting over a puzzle sheet. Yeah. So, quiet is underrated. Donna, I could not agree more. I go from like an extroverted teacher to absolute quiet. And I expect my kids, whenever I have my eyes shut, they are quiet. And there's nothing wrong with a 5-second pause many times in your math classroom. That's the right way to teach, focuses the kids. Okay, so has everybody found a position to put their name in this Venn diagram? Lori, thumbs up. Daniela, thumbs up. Sloan, Donna, Karen, Lisa. Sloan, you just got a cat. Congratulations. Okay. So now I want you to think about somebody else in your life. Okay, can you put their name in there? Okay. So I'm going to so now I'm talking to you like teachers, not like kids. So I would not say this to the kids, but there is a problem here. So think of somebody else in your life until you find a problem with this Venn diagram. Right. So if you're an only child with no pets, there is no problem. You are writing your name outside these 4 circles. Okay, so there's no problem with that. That is also true of the 3-person Venn diagram. Okay, the outside is a totally legitimate area to write your name. Okay, so nothing wrong with that. Only child with no pets. So Karen, you're okay. No animals, no sibs. No, there's another problem here. And your kids will figure it out because, in an average class of 24 kids, one child is not going to be able to place their name in here, guaranteed pretty well. Which child is going to have problems? Right. So Lori, you know somebody who has a cat and has a sister, but does not have a brother and does not have a dog. Where do you put your name? So you don't give it away immediately to your kids. You say, can you help that child? Can you help that Audrey put her name somewhere? And sure enough, kids are going to volunteer to help her, and other kids are going to say no. And so this can be a really nice discussion. There is actually no place for Audrey to put her name. There is no place for someone who owns a cat and has a sister, but does not own a dog or has a brother. And the same is true for someone who has a brother and owns a dog, but nothing else. There's no place for them. So then I joke that they're kicked out of the room, that they don't belong. So that's, I love playing with humor like that. But is that failure of this diagram a reason not to present it? Absolutely not. Your classrooms must be filled with problems that are impossible to solve, and you keep a straight face. They must be filled with problems that have many solutions, and you're not satisfied with just getting one solution. What about this? So that last one was not a Venn diagram. I called it a Venn diagram, but it was not a Venn diagram. What about this? Is there a problem here? So again, I'm not going to talk to you like kids. I'm going to talk to you as if you're teachers. There is a problem here, not quite as obvious. But the problem is that we have this region up here that is the same as this region down here. So Venn did not like that. He wanted people to have one and only one place to put their names. So if you have a brother and own a dog, you could put your name here or here. Venn did not like that. So this is not a Venn diagram. So you can discuss what are good properties of a Venn diagram and what are not. So according to Venn, there should be one and exactly one place for everyone to put their name. What about this? Is this a Venn diagram? Is there exactly one place for everybody to put their name? Again, I'm going to talk to you like teachers, not like kids. The answer is yes, this is a Venn diagram. This might take 20 minutes for you to go through this presentation up to now, not 10 like we've done it. So you don't have to feel rushed in getting to this point. Kids love going up to a whiteboard and putting their name on there. They love that physicality in grade 2. Now it's time for just some beauty. So here is just some Venn diagrams being created in an unusual way. You might not have seen this, but Venn diagrams can be asked for any number of questions, not just 3 questions and not just 4 questions like what we've seen. Here is 5-question Venn diagram, 6-question Venn diagram, 7-question Venn diagram. There is exactly one place to put your name, although some of those spaces look pretty microscopic to try to squeeze your name in there. There is exactly one place to put your name. Okay, there's another one. One of these Venn diagrams are actually the logo for Math Pickle, because I feel so strongly that it is the one part of the elementary school curriculum that is so easy to improve. Like, seriously, with just one sentence. I wonder if this is possible with 4 circles. With just one sentence, you improve the whole teaching of Venn diagrams. So that's why I made it the logo for Math Pickle, my website. One of the beautiful things, and now okay, so I know this is for grades 1 to 3, but it was proved in I think 2004, that the only Venn diagrams that are radially symmetric, that means that you can rotate them and they look the same apart from the color. The only ones that are possible are those that have a prime number of questions, like if that's not just totally beautiful. So here, for example, is a 7-question Venn diagram that you can rotate and it will look the same. I love this. Okay, there we go. Now, I love to experiment, and this is a puzzle that nobody has ever seen before. It's brand new for me thinking about using this in the mathematics classroom. I'm a mathematician. My primary joy is actually with the mathematics, not with the kids. Now, I love kids finding the joy of mathematics, but first and foremost, I'm a mathematician, and I love beautiful mathematics. And this is a maze that was, I'm calling it a maze. From 1884, a guy called Tate came up with some constraints of a maze. And the idea is that you have to start at any one of these gray circles, and you have to wind yourself around the maze and return to your gray circle. Obviously here it's impossible. So he had some rules. The rules are that every single one of these gray points must have exactly 3 edges coming out of it. The first rule. The second rule is that none of those edges can intersect each other. So that one, both of those two are fine. Every one of these gray points has got exactly 3 edges leaving it. And none of these edges intersect. The last rule is that you can't cut the graph in 2 by chopping 1 or 2 edges. You can't do that. So that's where this graph fails, because I can just chop right in the middle and I have cut the graph into 2 bits. So this is a failure. This is not what I'm calling a Tate maze. Okay, so let me show you an example of a Tate maze. So here is a Tate maze. Can you find a way to visit all of these gray circles and find your way back to the origin, back to where you started? So this is a brand new puzzle. I thought that, so Donna, this is an Euler, this is not an Euler cycle, it's a Hamiltonian cycle. An Euler cycle, an Euler path, means that you visit all of the edges. I'm not asking you to visit all the edges. I'm asking you to visit all of the dots, all of the gray dots. So Euler and Hamiltonian. Like, my name is Hamilton. I wish I had created this, but I didn't. So we're looking for a Hamiltonian cycle, a cycle that goes through and touches all of the dots, goes through all of the dots once, not twice, just once each, and returns to the original dots. Okay, so let's. You can imagine that I could try to do this here. So this is going to be crude, and I don't really want to do this here. I just wanted to show you guys that I just love creating new stuff. And so this is my new puzzle of the week. And I will be presenting this at a conference. I'm hosting a conference in August to select one proof, K through 12, for every child in the world, because they're so beautiful. Beautiful proofs are so beautiful. So here, have I succeeded? I'm doing pretty well, but not very well. Do you see where I failed? So here we go. Here we go. And pretty good, pretty good, pretty good. But a problem. I have missed 2. I've missed this one here. And I've missed this one here. Okay. So this was a failure. Whenever you're explaining puzzles to kids in front of the class, just fail. Like, just keep on failing. Just like fail and then say, I know how to do this, and do it again. And, oh, you failed again. And then you do it again and oh, you failed again. So that's just entertaining for young kids. We can all learn a lot from clowns. And the way that clowns interact with kids, I know clowns have got problems right these days because of some bad movies and stuff. But the way that clowns used to interact with kids, that is really what I, visiting a math classroom, can do all of the time. Maybe it's different if you live in a grade 1 classroom. Then you have to command respect. But you have to balance that, needing to be respectful and needing to be a clown. I do that. I will turn like this from, if I need to have classroom management, I will turn like this from being absolutely sharp to being very much a clown. And I'll just go back and forth between those 2 roles. So that's just my technique. You want to experiment. If you're a teacher starting out, teaching really is an experiential art. I don't have any teaching degree. I am purely a mathematician. But just by experimenting and watching great teachers and just just it really is an experiential learning about yourself, learning about how to interact with kids. A great way to give yourself the freedom to fail in front of the classroom. Okay. I am now we're going to go back into your breakout rooms, but only if you guys, like, was that working for you? The tables? Can I get a show of hands if it's just better for me to talk, or if that was beneficial for you to go back in there and explore? Can I just get some opinions if you want to go back into those rooms after I explain a puzzle? This is a new puzzle. Okay, Lori says, keep talking. That's not a problem. Can I have another opinion? Yeah, maybe I paid Lori to say that. Okay. So yeah, I'll just keep talking. This is an unsolved problem of mathematics from 1967, and I think it is the most important single thing that should be added to curricula worldwide. I'm trying to get $1 million reward for this puzzle. I've been trying to do that since 2013. That's a long story. But everything that I show you now are just small little examples of this unsolved problem. And all of them can be solved. Okay? It's the bigger picture that's unsolved. Okay, so how are we going to solve this? Well, whenever I show kids this, I do not tell the rules of the game. Instead, I want to engage them emotionally. Whenever I come into a grade 2 classroom, I want to engage those kids more than I want to teach them. Okay, I want to have high engagement up front. So how do I do that? I do that by immediately calling on Donna. Go ahead, tell me where to put this number 1. Do you want me to put it up here, at the top, or at the left? I'm going to turn that to a black number 1. Where do you want me to put this? We're looking at odd consecutive integers. So where do you want me to put this? Donna, it's your your choice here. I could put it at the bottom here. I can put it over on the right at the beak. Where do you want me to do it? At the beak. Okay, we've got the beak. Okay, good. Number 3, car. Number 3. Where do you want me to put number 3? Right in the middle or at the top? The left. Middle beak. Okay. B is saying middle beak. Good. Number 5. Okay. By the eye. Okay, right over here by the eye. Good. Okay. And number 7. So I'm choosing different kids randomly here. These kids have no idea what they're trying to do. No idea at all. Is that important? No, it's the engagement. They're part of this puzzle now. They have no idea what the heck they're doing, but they're part of the puzzle. And the number 9. Okay, so there we go. And then I say, okay, let's see if we can ride this emu. We get to ride the emu if all of those numbers are different. If the differences of connected circles are different. So 9 minus 1, that is 9 minus 1. That's 8. That's 8. So that looks good. And of course, I'm getting kids to contribute this. 7 minus 1 is 6. This is looking really good. It looks like we're going to be riding this emu, kids. 3 minus 1, that's 2. Looking good, looking good. And 5 minus 3 is 2. Oh, no. We failed. We've got 2 2s. All those numbers have to be different. So, failure. Kids need to be introduced to failure starting at kindergarten. Too often in Canada, and same as in the United States, you have parents advocating for gifted children. They say, my child is gifted. He's not being stretched enough in where we are in the class. So can you just accelerate him through the through the curriculum. And what happens is that those kids hop, skip, and jump their way through to university. Success to success to success to success. They hit university, splat. University is not where you learn to fail. You learn to fail in kindergarten. And we have just failed, all of us together. We have failed to ride the emu. So you can group the failure together at the start in a kindergarten class. I would never go in and say that one kid has failed. Instead, we all fail together. I can also call it something different. I can also say, for example, with this one, I can say, oh, you fell flat on your back. Oh, okay. So that's failure. But what kid doesn't want to have me going, falling flat on your back? Well, all the kids find that funny. The kid who made me do that action finds it funny. So everyone's okay with a single kid failing if they're okay with it. So you can change the wording, you can, but you're getting them prepared for failure so that the whole class is liberated. You saw how I asked for a failure whenever we were doing Uncut Spaghetti. Okay, so you are all the time trying to prepare the class to be okay with failure. For you to mentor failure yourself, that just makes the class so much alive that kids are going to be volunteering answers. They don't care if they're right or wrong. They want to come up with hypotheses. I think that this is true. And then you're going to be shooting down those hypotheses. By grade 5, I've been working for the last 4 months. I've been streaming into this classroom in Texas. And at the start, the kids may be hesitant to come up with hypotheses. But every time a child came up with a hypothesis, I said, good, I want a hypothesis. I don't care if it's right or wrong. I just want a hypothesis. Now let's see, can we break it? Okay, so it's a much more exciting way to teach mathematics. Okay, so can you guys play around with this? What happens if we flip flipping the 5 and the 9, I think that's going to work well. Because now, you see, I don't have 2 2s. So I think this is going to work. Here we have 5 minus, that's 1, that's 4. This here is 9 minus 3 is 6. And we've succeeded. So all of them are different. So we have succeeded in riding the emu because all of these numbers are different. Okay, good. So how do you handle a parent who says that by using the word fail, you are shaming their child and your principal writes you up for being disrespectful to the children? So I'm no expert at dealing with those kind of situations. So I'm sorry that you have to deal with those. I just know what I want to see in the math classroom. And if the child is really feeling that, then that's a problem. That's a problem. And I've had situations where I've had problems with kids. I've gone too far. So I've failed myself. So whenever I am recruited by a school to go in and talk and interact with them, the first thing I say is, I'm going to be experimenting on your kids. I'm going to be failing part of the time. All of your teachers should be given that liberty to fail part of the time as they learn the art of teaching. I am privileged to have a PhD, so people look to me and give me freedom that they sometimes don't give teachers. So I make sure to say that's wrong. Teaching, you need to have the flexibility to fail sometimes. And exactly right, Laurie, this is not a success. This is a fail. Donna, correct. So exactly, be a clown, make mistakes yourself in front of the classroom. So obviously a mistake that I made here. Of course, yeah, so you make these on purpose up to about grade 4, grade 5. After that, you tend to, like I personally make mistakes. I'm not a very accurate mathematician, so I make mistakes naturally from about grade 5, 6 on. I don't prepare well, and I just make mistakes naturally, and that's exciting for the kids to catch me. So, okay, so you guys have solved it for. You guys haven't solved it for this, but we're going to go on to this number anyway. To this one anyway. Kids love this because, of course, not only are you dealing with beautiful mathematics that's not obvious for their age group, you're also dealing with beautiful images. So I believe in physical beauty throughout the mathematical experience, kindergarten through grade 12. You're going to be engaging 15% of your kids more if you can bring beauty to your math classroom. For me, that means beautiful slides like this. I try to produce them and photocopy them and have them laminated for the kids or something like that. Photocopied that are smudged and just of poor quality, I hate that. I love beauty. I love beauty in mathematics. I love beauty in the physical artifact that I give to the children. I take pride in making puzzle sheets that are beautiful. So here, after they solve the first one, as a group, then maybe some of them get this starfish. How are we going to solve this? So this might look more difficult because we're dealing with odd consecutive integers 1 to 11. The last one was only 1 to 9. This does not, 15% does not come from anywhere. It's just my, the number that I place on it. Okay. None of what I do on Math Pickle is scientifically based. I don't have time to do research. I'm not affiliated with any university. I just do what I think is right in the math classroom. I put it all out there. And if someone can do research on it sometime in the future, I'd welcome that. But that 15%, purely here. Okay. Yes. Yeah, I think that by presenting beautiful stuff, there are some children in your math class, they don't really care about mathematics. If it's presented in a beautiful way, you get that extra little encouragement. Oh, at least give this a try. Like, it looks beautiful. Whenever I come with a beautiful puzzle sheet, there are some kids, whenever they make a mistake on that puzzle sheet, they want an entirely new puzzle sheet so that they can make it beautiful, that their answer can be beautiful. Is that a waste of time? Absolutely not. To be proud of your work, to be so proud of it that you are unhappy with making a single mistake in an old worksheet, okay. I might suggest to them that they finish it off, they have all of their rough work on one sheet, and then they transfer that to a beautiful worksheet that they already know, they've already done the math. Now they're just focusing on making that beautiful so that they're proud of it. That's never a waste of time. That's only a small percentage of kids. Okay, I'm not even talking 20%. I don't even think 15%. I might be talking 5% of kids who, the real artists, the ones who really care about what it looks like. Mondrian art puzzles, which I am not going to present today, but if you look up Mondrian art puzzles, that's probably one of my most beautiful puzzles. And that one, absolutely, I have kids that want to redo that. It's actually gone into art classrooms. So it's been taken up by the art teacher in a school. It started out in the math classroom and it ended up in the art classroom. So that makes me happy. Yeah. So any ideas about this here, where you would like to put the 1? And what is the unsolved problem here? Yeah, I only have a few minutes left. So let me just imagine that you're now teachers, not students. So one of the beautiful things about any star, not just a star with 5 points, but a star with any number of points, is that you can just put the 1 in the middle, or you can put the biggest number in the middle, and then just put all of the other numbers on the outside. Okay? And you're guaranteed to find a solution. So I'm just going to hop, skip, and jump through. The unsolved problem is that no matter what insectoid you choose, no matter what crazy animal that you choose, the rules are, for the unsolved problem, the rules are that there can be no loops and that all of your circles are connected. Okay, those are the only two rules that you need to construct these. And absolutely, children should construct their own. But you need to be, they can draw the diagrams, but you need to be in charge of how many circles they put down, because this problem becomes extremely difficult as you get up to higher numbers. So linear ones, okay, these ones don't get more difficult. You can find a pattern to those. But as we go up, we've already talked about these stars, these star-like patterns. They all have this, they're all easy to solve. But as you get up to larger insects, even something like this and this spider, these are actually quite challenging to solve. You can doodle this yourself. You know, if you're standing in a bank lineup yourself, you can put these down, and then you can try to put in odd consecutive integers into these circles and try to find so that all of the connecting circles, all of those are different. Okay, this is not easy. So you do not want your children to be drawing a Tyrannosaurus Rex and then drawing 20 circles. 6 is enough for most kids. 7 for pretty good kids, maybe 8. But going to 9 like this, it starts to get really hairy. So just know your children. Do not let them be in charge of how many circles they put down. The unsolved problem from 1967 is no matter how you design your insectoid, is it always possible to solve? Or is there one of these insects that you can never solve, that you can never end up riding that emu or jumping on that spider? Is there some insect or some insectoid that is impossible to solve? An unsolved problem from 1967. It's called the graceful tree conjecture for any mathematicians listening. But of course, you don't need to tell kids the graceful tree conjecture. You can just call them this is, animal subtraction or whatever you want. Okay. On Math Pickle, this is called animal subtraction. And I have all of these diagrams, I believe, on there. I have 8 minutes. Now, I could go into a new puzzle, but I think I'm going to just open it up for question and answer for these last 8 minutes. Thank you, Spencer. So, any questions? Okay. So, enjoy teaching. Yeah. So Donna says, my students, middle school, love to find my mistakes. It empowers them. Absolutely. Mentoring failure is one of the most valuable lessons that you can give your kids. Whenever you fail, you don't pout at your desk for the rest of the class, and you don't feel intimidated by your kids. We're all in the same boat, and some kids are beyond smart, and quite often those kids are faster than we are, and that is okay. I found an age 5 child in Philadelphia at one Julia Robinson Math Festival, and I was amazed at this child tackling a grade 8 problem Okay, so this was a 5-year-old tackling a grade 8 problem, and whumping it, like just whumping it. By age 7, that child was doing number theory at a university level, had an IQ of, did 2 IQ tests and went beyond on both. So, that child far superior to myself as a mathematician and as a thinker. So we all have to have the humility, and that's just a beautiful part about being a teacher, is that the best teachers are often those that are just humble about finding their way through this fascinating subject matter. So those puzzles should be, animal subtraction should be on there. And you know what? I'm going to share my email in case I don't have them on there. So it's gord@mathpickle.com. So if you do want to get a hold of me. The other thing, yes, in the last 5 minutes, I know what I'm going to talk about. Sorry. As the teacher, are we allowed to change the rules of the puzzles, or do they come with the rules that we have to follow? Of course, you're welcome to change the rules. Danielle, what I would ask is, if you think that your rules are better than my rules, then please email me. I want to know your rules. I want to put them up on MathPickle. Okay? So if you want to use any materials, you're free to use them on MathPickle. Everything's for free. But if you come up with a gem, then please tell me about it, because we're all learning together how to do a better job. So how am I going to spend the last 4 minutes? I am going to spend the last 4 minutes in what I believe is the most important message that you can give to parents to help support you in the math class. And that is not to give them worksheets to do with their child at home. It is for the parents to adopt a board game. As a board game designer, I might be biased, but I don't think so. I think board games are the best way to celebrate problem solving. And problem solving is really what we are all about in elementary school mathematics. Whether the children learn arithmetic is number 2. Number 1 is that they become sharp problem solvers. And there is nothing like a board game that they have to beat their parents every week. There's nothing like that board game to celebrate problem solving. There are lots of board games recommended on mathpickle.com. So I encourage you to tell your parents that. That's the number 1 thing that they can do to help their child. Not all board games are created equal. So please, Monopoly and Risk, those are games from the past. Yes, there's new versions, and some of those new versions are pretty good. I think for Risk, there are good new versions. But check out mathpickle.com. I've only got one of my games listed, Santorini. That's the only one that I'll recommend of my games. All of the others I am recommending without bias, because they are not my games. I wish I had created them, but I didn't. And there are some gems. We are living through a renaissance of board game design. It is a fantastic time to be alive. And these board games don't belong in the math classroom. Pieces can get lost. They're too expensive. There's all sorts of problems. The time just isn't right. 45 minutes, you have to be done. What happens if you're 10 minutes into a 20-minute game? It doesn't work well. So board games, for the most part, belong at home. Yeah, for my children, there's books and there's board games, and the 2 of them are equally important. You do not have a choice in my home whether to play board games or not, just like you do not have a choice whether to read books or not. Both are important. You learn how to fail playing board games. You learn how to think. You learn eye-to-eye contact with your parent. Like I have teenagers now. I can tell you, I still have great eye contact with my kids. And maybe part of that is because of board games. So, yeah. So I'm thrilled that you have after school clubs. If you don't have a chess club in your school, please don't start one. There's much better pure strategy games to start. If you do have a chess club in your school, by all means, keep it up. But there's much simpler rules to equally beautiful board games. So those are on Math Pickle as well. Pure strategy games that I'll recommend. Some beautiful ones. Not expensive, faster than chess, and easier than chess to learn the rules. So, okay. Good. Okay. My time is up. You guys take care. Bye-bye.